Now, what I was going to say about males and breasts. Make sure this is on. It's good stuff. We can't miss this. Yes, at least in the form of primates, especially in gorillas, there are still residual traces of mammary glands in primates, and we are primates as far as scientific classification in terms of our species. As far as the ability to have hormonal-induced lactation and the ability to breastfeed, that's sort of sketchy. It's accepted that among humans, no one has messed around with gorillas enough with this, I think, to really find out for sure what their capabilities are. But as far as humans go, it's generally accepted that in some cases there are residual mammary structures that theoretically do still possess the ability to produce and secrete a little bit of milk. I was watching a few years ago, there was a documentary about a guy, and him and his wife, and they were real tree huggers, and they lived way out in the middle of nowhere, and he was all spiritual and metaphysical and he thought that he could overcome that and actually breastfeed his son or daughter or whatever, I don't know. And we know, and I'll talk about this a little bit later, that the suckling reflex, actual physical stimulation of the nipple, can induce higher levels of oxytocin. That's one of the things you can do, physical stimulation to sort of induce contraction to make that process happen a little faster. Now, there's side effects of that. It depends on who you talk to. Some people say it works. Some people say it won't. Some people say when it does work, it makes the contractions harder. It just depends on your experience, who you talk to, whatever. But point being is that he stimulated himself and as well let the child continue to suckle, and it took a while. But he claims that he had one breast that would actually produce milk, and he was able to feed his child. As far as what was controlling that, as far as scientific documentation proving that, it was just a documentary. I mean, there was no other evidence available. As to whether or not there are other claims out there, it's part of the reason why I wanted you to research it, because I haven't really thoroughly researched it. I don't know what's out there. But as far as the general capability, I mean, we do have, males still have nipples. So, I mean, there's at some point along the line, there must have been something to trace back, even, like I said, a small step backward to the other primate species. There tends to be that capability. So, but we don't find the males among mammals. We don't find the males being the ones that feed the children. It's interesting. It's kind of odd if you really think about it. It challenges certain things that you believe in terms of cultural norms and that kind of thing. So who knows? I don't think that's enough evidence for you to go home and try to play that card or anything. If those of you who are planning on having children, I don't think that may be something you want to look too hard into. Number one, do you really want the male to be responsible for the feeding of your child? But anyways, I left off here, I think, talking about tropic hormones. I had a group of 6 of these hormones. Remember, there's a difference between the anterior and the posterior pituitary. In the anterior pituitary, we've actually got glandular tissue that are going to be cells that release hormones. They're going to get a cue from a higher level up in the hypothalamus. The posterior pituitary is nervous tissue. It is going to just be a link between the neurons that are in the hypothalamus and that are transmitting these chemicals down through that portal system, down, extending through, and releasing it in the posterior pituitary, and that goes straight into the bloodstream. So there's no glandular tissue in the posterior pituitary, no second step, so to speak. All right, so I'm going to go over all of these and the implications of all these, but here's the only time probably we'll see them all together like this. These are not in the hypothalamus. These particularly right here are going to be in the anterior pituitary. We already discussed the two that were in the posterior pituitary. What were they? Oxytocin and vasopressin, which is ADH. Okay. All right, so let's take a visual here. Here is the anterior pituitary, the front part. Notice you'll see 5 circles. There are actually 6 hormones. But what has happened is those sexual hormones, they're very closely related. The follicle-stimulating hormone, the luteinizing hormone, they're grouped together into one here. That's why there's only 5 circles on this chart. All right, so we've got thyroid-stimulating hormone. It's going to stimulate your thyroid. Next lecture, we're going to look at that. If I get to it today, we'll look at how this works and how the thyroid produces what it does. So it acts on the thyroid gland, and then the thyroid gland, in turn, from having received this stimulation, will produce your thyroxine, your thyroid hormone, which is actually composed of 2 things, T3 and T4. I'll talk about those later. And the most important thing that this is going to influence, other things as well, we'll talk about those, but your metabolic rate. Okay, your thyroid is going to help control your metabolic rate. Okay, adrenocorticotropin hormone. This is a main tropic hormone. It receives its cue from higher up from the hypothalamus, and then it interacts, and then that'll feed down and cause this to be released. Where is this going to go? Adrenocortex. Okay, so it's going to travel through the blood, get down to the adrenal cortex. When it gets there, there's going to be target cells that are designed to interact with that tropic hormone. And one of the biggest things that are going to come out of this, again, there's others we'll talk about, but the biggest thing is the release of cortisol. Do you remember what cortisol does? I know here it's listed as metabolic action stress response. We discussed it before. I don't know if you remember. We discussed it in the immune system. Was one of the places we discussed it. Cortisol is a stress hormone. It's associated with the sort of fight or flight, the increased stress response that our body gives off. Remember I talked about like cortisol and weight loss, things like that, steroid-type hormones. Cortisol, I'll come back to it later, but what it's going to do is mobilize your energy stores. It's going to take fats, proteins, stored glycogen in the body, break all that down into usable energy, get it circulating, going through. That's sort of why you get weight loss out of it. But one of the bad things that happens is what? Do you remember? Oh, well, okay, maybe. But immunologically speaking, you remember what happens? You lose what? Well, no, I'm just rolling this in my hand. No connection. No charades. Just, it's not, don't make it harder than it is. Well, don't worry about specificity here. You just lose general immune response is what you get. Your immune system is decreased. It's weakened. One of the side effects of taking this is one of the side effects of cortisol is, okay, maybe you'll get some weight loss, at least systemically speaking. But at the same time, you're breaking down fats, which can lead to acidosis, especially like when that happens in the liver. Ketones and acidosis can set in, and also your immune response decreases because it's one of the triggers that help control immune recruiting for blood cells and things like that. All right, well, anyways, the third one on this page is prolactin. Pro is sort of like, in favor of, helping, so you can see that it's going to be influencing lactation. Prolactin is going to affect and go to the mammary glands and going to help promote breast growth during pregnancy, as well as milk secretion. You'll find that oxytocin has a twofold. Number one, I'll get there in a sec. Well, I guess we already talked about it. We'll talk about it again later. But oxytocin is obviously responsible for uterine contraction. It helps, I mentioned that before, Pitocin, oxytocin. But also what oxytocin will do is it's involved in breast development in terms of the lobules that are going to sort of get bigger and grow that are going to produce and store this milk. The actual ducts, D-U-C-T-S, okay, the ducts that develop in the breast that will channel this milk, that comes from the effects of oxytocin. Prolactin actually is just the secreting of that milk in the general breast development. So together, they're both going to be important. All right, so there's 3 of them, TSH, ACTH, and prolactin. Then we've got growth hormone. In its most generic sense, growth hormone has to do with, just general growth. But realize that there are a lot of things that go along with that, such as if you're going to grow, what do you need? You're going to need your bones to lengthen. The cells are going to have to, new cells have to form and grow at the ends of the bones. You're going to have to change your metabolism. Things are going to have to start breaking down and start pulling out your energy stores. So what you'll find is the growth hormone has a lot of effects on subsequent hormones that are related to all that kind of stuff, not just physical growth, but all the things that have to accompany that, metabolism and bone structure and that kind of stuff. So, I guess my point is that it's not like it's just a one-time thing. Growth hormone is not just important during adolescence. It's important from the beginning all the way to the end of life, because all of these same things that are involved with growth, yes, all of that happens at a greater rate at a particular point in our life, but yet still happens to maintain homeostasis all throughout life. So it's still important. All right, so here we've grouped two together, luteinizing hormone and follicle-stimulating hormone. This is going to be with gametes. Gametes are sex cells. Okay, so eggs and sperm formation, as you'll find down here. Okay, both of these they're grouped together here because they're both going to the same place. They're both going to the gonads, the sex cell regions. They're going to go to the ovaries. They're going to go to the testes. But they act on different cells in each location. The FSH, follicle stimulating, it's going to stimulate the follicles, which are going to hold the eggs. So we've got eggs in females, sperm in males. That's what's going to be triggered by this. Now, luteinizing hormone is for the actual secondary sex characteristic kind of stuff, the estrogen levels, the testosterone levels, sex drive, hair growth, size, deep voice, all that kind of stuff that's going to be controlled from all of this, which is actually separate than what's going on over here. This is a formation process. This is a overall type of process. Okay. All right. Now, what you see here is actually a step higher. These don't get as much recognition as the other ones because all these guys right here seem to be the crutch, because this is sort of the not all the way at the top, but right where it has the most impact. These 6 that you see here, all up in here. These guys here that you see are actually the ones from the hypothalamus that control all of these right here. Okay, so it makes sense. Their names. I just have the letters up here, but you'll see that the names are very easy to deduce considering what it is that they do. TRH is thyroid releasing hormone, which is going to come down from the hypothalamus and go into the anterior pituitary to release thyroid stimulating hormone. Thyroid stimulating hormone is going to leave the anterior pituitary, go down to the thyroid, and cause the thyroid to produce its hormones. It's a whole big chain reaction. Okay, and then the products negatively feedback and shut the process down once they're formed. Okay, so we've got corticotropin releasing hormone to stimulate adrenocorticotropin hormone. I know there's a lot of words flying around, but you can systematically break these down. Once you learn one level, then you can figure out what's above and below it. Gonadotropin releasing hormone. It's going to trigger the release of follicle-stimulating hormone and luteinizing hormone from the anterior pituitary, which are going to go down to the gonads. Growth hormone releasing hormone. All of these are releasing hormones if you haven't figured that out. Growth hormone releasing hormones. Guess what it's going to do? It's going to go down to the anterior pituitary from the hypothalamus, cause growth hormone to be released. Then when it goes out, it'll affect all the different areas of the body. There's also a check to keep this balanced here. Growth hormone inhibiting hormone actually can be released from this spot too, to inhibit the release of the growth hormone. A prolactin releasing hormone is going to stimulate the release of prolactin. Again, we have an inhibitory counterpart there to keep that in balance. So the point is, there's a communication between the hypothalamus and the anterior pituitary. Okay, so know that chain of command. It's not going to be too hard to remember if you just sit down and think about it. Yeah, but I mean, you can figure out what these are. I'm convinced of it. I'm convinced of it. Okay, and all this is a flow telling you what stimulates what. You can follow it all the way through. Like if a stress response, if your body is experiencing stress, what's going to happen? We already mentioned from basic anatomy, that the hypothalamus is the center for homeostasis in your body. There's so much stuff that happens in your hypothalamus, we can't even begin to sort of separate it all out and break it down. All we can do is just witness what happens. And one of the things that happens is the hypothalamus, some cells in the hypothalamus are going to trigger the release of one of these guys up here. In this case, it's going to be this guy, corticotropin releasing hormone, because cortisol is associated with stress response. Learn that at least. Because if you know that, corticotropin releasing hormone is going to come out from the hypothalamus. It's going to go down into the anterior pituitary, and it's going to cause, that's this path right here, then it's going to cause adrenocorticotropin hormone to be released from the anterior pituitary. What's going to happen then? That's going to go out, go into your body, flow all the way around, hit your adrenal cortex. It's going to cause the release of cortisol into the body to respond, okay, to that stressful situation. Now notice that this stress, what is stress? It could be mentally induced, right? So there's actually a neurological connection between the hypothalamus and the brain. Obviously there has to be. It's all the same type of tissue. But something in your brain tells your hypothalamus. Realize we've just skipped over a tremendous amount of knowledge right there. But something in your brain triggers the hypothalamus so that when you're perceiving a stressful situation, all of this happens pretty quickly in order to get cortisol out into the bloodstream so that you can handle that stressful situation. You can break down stuff, put more glucose into the blood, that kind of stuff. All right. Questions? All right. We've already talked about this, the vascular link, the hypophyseal portal system. That's just that little stalk between the hypothalamus and the anterior and posterior pituitary. So there's communication, a lot of communication that occurs in that small area. So that's what this is about. I already mentioned negative feedback. Okay, so whatever is produced, like if corticotropin releasing hormone comes down from the hypothalamus, goes into the anterior pituitary to release adrenocorticotropin hormone. Adrenocorticotropin hormone is going to go out into the body, float around until it gets to the adrenal cortex, where cortisol is going to be released, and then the products of cortisol are going to feed back and shut down from the top down, all the way back. Okay, that's all that negative feedback cycle. So there's a close-up of it. We've already talked about it.
Why do they give growth hormone and Brinson on that
Wait, why what? What's
well, why do they?
Well, I mean, it depends. If it's a hormonal condition, well, I'm going to talk about this a little bit. Well, bring that up again when I get to conditions associated with the growth hormone. Because, you know, there are conditions, hormonal conditions, that you could not grow as tall as you're going to or develop as much as you should. Oh, you're saying there was nothing wrong with them, they were just short.
Right.
Oh, well, I don't know. That's a choice that they can do, I guess. I mean, if the doctor agrees to it, I don't think there's any regulations against it. I mean, if there's a hormonal problem, then, you know, supplementation and bringing back in of that hormone can fix the problem. But as far as why it would work on some cases and not others, I mean. No, I didn't see it. I don't know. All right. As far as we know that I said before, growth is what's signaled by the growth hormone. Now we do know that there's a lot more to it than just the amount of growth hormone that you have, right? You think about, well, look at generations past. You know, I'm not a tall